Hey everybody, and welcome back to another video on my channel. So I wanted to make this the last video of the little mini series of how to interact, with objects. So in the second video in the series, we looked at creating these blueprint actors that you see here, where we briefly discussed parent and children, right? And when looking back at the video, I kind of wanted to give a recap of that because I felt like I didn't explain it well enough in regards to parent and children. So when we look into it and go to our blueprints, basically what we're trying to do, and you're going to see why we have parent and children. So basically what you want to do is default stuff or functionalities that you want between like every object of a similar type to have. You would want to create a parent and put those default functionality or values in that will then spread across to all your children. But then you want children in case you want to do different things with them, like slightly different stuff, like I mentioned in the previous video, where when you create the parent, like let's say we want to give, it's going to be for actors or characters or like AI and a player character, where they're all going to have health, stamina, wanting to attack, have attack damage, defense, stuff like that. So that would be something that you'd put in the parent, so it splits across all the children. But then let's say you want the player character's attack to grow exponentially with your functionality, and you don't want the AI to do it. That's where you would then put in your separate functions, where you would place those in your children. So that's just kind of like a quick basic recap or a better explanation in regards to that. And then in the first video, we made our interaction line tracing, where our function is going to have basic inputs that I wanted to put in or worry about when it comes to line tracing. So in this video, we are going to create a blueprint interface and do some checks based on our out hit and return values to make sure that we are interacting with the stuff that we want to interact with. So the first thing we are going to do is I'm going to hop into the content drawer and go into content, and I'm going to then go into blueprints, and in here I'm going to make a new folder called interfaces. So typically what I like to do when doing different stuff like this, like say if I create actor components or if I create interfaces or data files, I like to keep them in folders like these on the main level of where our blueprints are, just because these are a lot of the things that we do use within blueprints. So especially within our main stuff, right? So that's typically what we would do. So what we're going to do is we're going to open this up, and we are going to then create a blueprint interface. So what we want to do is go into blueprint and then create a blueprint interface. And I'm going to call it BPI, short for blueprint interface underscore interaction. Just like that. And I'm going to explain what a blueprint interface in just a moment. So let's go ahead and open this up. And in here, you'll see that we have a read-only space interface with a new function. So in here, let's go ahead and call our function interact. So to briefly explain what the blueprint interface is as well as I can, because even sometimes it still confuses me to a certain degree, especially with how to use them, but this will be like a basic use case of how to use them. You can definitely get more complex to it. So in this instance, think of a blueprint interface as like a portal where you can't modify the portal. You can't do anything special with it. However, you can input stuff into that portal and it'll immediately like come out the other end to wherever the recipient is or whatever you're trying to do with like, an object or information where it comes out to. Like, another thing would be treat it like a cell phone where, your cell phone has specific functionality, and when you hold it in your hand, and you are calling somebody or talking to somebody on the other end, you're essentially providing information or whatever you're speaking into the phone, and then the recipient at the other end is immediately getting that information or being passed that information to the recipient through their phone. So those are some like basic contexts of like how you want to treat blueprint interfaces. Because in here, as you can see, it is a read-only blueprint. So read only essentially means that you cannot modify this or do anything, because as you could see when I try to right click to put stuff in here, you cannot create new nodes, so you can't put any functionality in here. However, what you can do is you can put inputs into it, right? Like as you can see, we have new param 1. We can change it to like provide it a vector or a float, stuff like that, right? So think about it in terms like this. If I went back to my sandbox character, if y'all recall in the first video how we made the function here, if we go into it, we basically just tied a bunch of nodes into this interaction line trace beginning function, or the start point of it. And then whatever we feed into here then gets thrown into here. It gets passed into our line trace. And then we have a return node to then signify like, hey, return this information, return that information. So BPIs, or blueprint interfaces, are kind of similar. It's just that you don't have any in-between functionalities. What you're wanting to do here is like pass information from here into wherever its output is. So like, again, like a phone or a portal that you're just putting stuff into, and whatever the opposing side, or the, you know, the destination of that portal or the phone of the person you're trying to call, it is passing that information over to that, whatever that information may be, to the location or intended recipient. So once we have that set up, we are basically good. That's all we need to make in here. We don't need to make more functions. We don't need to put in any inputs, anything like that. So once you have that, go ahead and hit compile and save. And we're going to then close out of the BPI interaction because we don't need it any longer. So the first thing we are going to do is we are going to then go out of our sandbox character, and we're going to open up our content drawer, and we're going to go to content, back to our starter content like we were in the previous video, and then we're going to go to blueprints and then go into our interactable objects. So like I mentioned earlier with the parent-child classes, and especially what I tried to explain it in the previous video, you're going to now see why we have a parent. So when we go into BP Interactable, because that's what we want to open up next, when we go in here, what we want to then set is our interaction, or our BPI interaction. So in order to do that, what you would then have to do is go into the class settings right here, because we're trying to get the overall settings of our BP Interactable, and that especially too, that's the only place where you, so far that I'm aware of, that you can put like blueprint interfaces in. So to put our interaction, or our BPI interact in, we need to click add, and then you will see that when we do that, there's a bunch of different blueprint interfaces that come up that are pretty much built into the system. Don't worry about these unless you know exactly what these do. However, what we want to look for is our interact BPI. So if I go in there and type in interact, you'll see that what we created earlier, our BPI interaction, is there. I don't know why transform gets created, and I'm not sure what these other ones do, but what we want is this first one for our interact, because that is what we created. So once we've done that, you'll see now that our interface then converts to interact, because that was what we put in as the function name within that blueprint interface. So once we have that, now go ahead and hit compile and save. And now what'll happen is if you go into your door chest blueprints, you'll now see that the door has the interact interface, and that the chest also has the interact interface. So that's what I was trying to explain with parent children, where because with our interactable that we set up an interface in it, it now spreads between every object now that we create. Off a child off of that BP interactable will now have the interact function, because it will be tied to the BPI interactable or interaction. So what we want to do now, we're going to start with the door first, because we now have to make our stuff now, our functionality for the interaction. So we're going to hop into the event graph. And what I'm going to do is I'm going to delete all of these. The reason why I'm deleting all those is because for the event begin play, there's nothing we have to initialize. Nothing at all. It's not like we're trying to create the interaction based off of that, because what an event begin play does is it initializes whatever you need to one time, like based on like at the start of the game. So say for example, you may have seen tutorials where it's like, hey, set your references up here, like your player input, stuff like that, checking for is valid, you know, whatnot. And then maybe they would say like set your widget or whatever if you made like a scoreboard on the begin play. That's this kind of stuff that you would want to do on begin play, where as soon as the game starts, you initialize everything and it's only gone through one time. We don't need an overlap, because with our BPI and how we have our line trace set up, there's no need for any sort of like overlap to where we need to be like within a collision box to then hit E to interact, you know what I mean, stuff like that. We don't need that kind of thing. And then we also don't need event tick, because there's not something that we are trying to retrieve every frame or every tick of our game. So now that we've deleted all those, we're going to now go into our interfaces and we're going to double click the interact. And what that'll do, as you can see here, is create a custom function called event, you know, whatever we named it. So you can have event interaction, event interact, or event enter, or event act, whatever, however you want to, whatever you want to call your interact or that custom function. And you'll see here that it's from our BPI interaction. So the reason that we are putting the event interact, or you know, this custom event in the interactable, is because we want the interactables to be like how you want it to function. So there's a video that I've done called WTF are vectors, where I briefly mentioned like moving platforms. So what you could do in this form, or this version as an example, is if you were to set up a moving platform where when you hit a button, the platform moves, right? Well, what you would end up doing is you could set up a BP interface, like, or an event interact custom event on the platform where, you know, you would have things done, or a check where it's like, hey, you know, is not moving, then move. And you're going to play like a timeline where it moves from one location to another, like over a period of time, like, you know, a moving platform. But then you would have like another actor, such as like a stand with like a button on it. And the button would be responsible for when you interact with it or push it, that it will then send a message or that phone call, or, you know, open up, go through the portal, you know, as per my examples, to then give the information to the platform to move. So that's what we're trying to do here by creating the custom event here, is we're trying to make this the designation of where when we call the function to move, you know, when we interact with the door or the chest, that it will then send that phone call or that information through the portal to our door or our chest to then open. So what we're going to do is we're going to create one function off the door, or not function, we're going to create one variable, and it's going to be called isOpen, because in here what we're trying to do is check whether or not it is open or is not, because we want to be able to open close the door, right? So what we're going to do now is I'm going to create a branch, and I'm going to then connect our custom event to that branch, and I'm going to then pull out a get node from the isOpen, and I'm going to then drag off and look for a not boolean. So the reason why I'm doing is not open, or, you know, not, and like a not boolean with the isOpen, is because I want to make sure that, you know, if isOpen is false, so if we compile and save, isOpen will default to false. So what a not boolean does is it inverses whatever this value is. So with us being false, as you can see when we hover over it, the not will then transform it into a true value, and then our branch will then continue off the true. If the isOpen is checked, the not boolean will then invert it or inverse it to a false value, and then in which case we go off the false. So not booleans can be very powerful as far as like depending on like the context of what you're trying to use it for. And with what we're about to use it for, you're going to see why we did that, because of how we are going to set up our timeline. So with that, what we are going to do now is we are now going to drag in 2 set nodes for the open. And we are going to, I'm going to copy that, paste it, and then put it here. And off the true, I'm going to hook it up into the top, off the false, into the bottom one. So off the is true. So if the door is not open, we want to then set it, the top set node to open to signify that we now have an open door. So that way, when we go back through this BPI interaction custom event, if the door is open, then we're going to invert that true value into a false and then turn it off, shut it off, basically, and then continue on here. So now what we are going to do is create a timeline. So in this case, what we're going to do is I'm going to right click in the blueprint and do a timeline. So a timeline is a very important node that you'll use for a lot of interactions, because what a timeline does is you give it a start point and an end point based off of a track that we make. So off of that track, you'll set specific values of how you want stuff to move. However, it doesn't have to be one singular track, which you will see in this video, just not with the door. So to demonstrate what we're gonna do, I'm gonna call this timeline open, close, if I can spell right, door. Just like that, because I'm not gonna say, that's the name I wanna give it, so I know that this timeline is gonna open and close the door. So off of the true path, we're going to hit play. So if the door is not open, set the Boolean to is open, because now the door is open when we play the timeline. And when the door is open, off the false, it is going to set false, and we want to reverse the door being open. So that's how we're setting it up here. So now what we have to do is set up a track for our animation to play out, or not necessarily an animation, because it's not going to be an animation. We're just basically wanting to transform the rotation of the door. So we're going to double click to open up the timeline, and I'm going to click add track, and we're going to add a float track. So this, I'm going to call it door delta. So the reason I'm calling it door delta, you can call it whatever you want, but delta basically in basic terms is the change over time to something, right? So, say for example that you do stocks, right? And you see that maybe the stock was, $10 at one point, but then the next day you tune in and it's $15. Well, the delta of that would be 5, because it had changed over a period of a day, $5, right? So that's kind of a simple sense, or a basic grasp of why I'm calling it door delta, is because we're making a single track to say hey, we want to change the door over a period of however long to 90 degrees or 180, fling open, whatever, right? So let's go ahead and add 2 keys to this. So you can either right click and do add key to curve float, or you can hold your shift button and then left click twice. So that way you don't have to right click in order to then create a key and then right click again to create another key. You can just shift left click one and then just shift click wherever else, because we are going to then set our 2 keys. So in the first key, you'll see that we have a time and a value. So I'm going to set the time for the first key to 0, because that is our start point. That is a start time. So at 0, 0, not at 1 second, not at 2 seconds, at 0 seconds at the beginning, I want it to be at a normal location, or its starting location. Meaning, so now we have to change the value to 0, because I want it to start at its 0 value on the rotation and at 0 time. So that's why we're setting the first key to 0, 0, because we want it to be at its starting point when the level loads, or the thing loads within our world. So then when we interact with it, we then want to then change the other key to have it fully swung open, at a certain time. So normally to get this key float down to what you feel comfortable with or the change that you want, you have to play around with it. But for me, what I've found is we're going to set it to a time of 1 second and a value of 90 degrees. So to find where our keys are, we're going to hit both of these buttons to zoom to fit. So as you can see at our 0, 0, we have a key there, and at 190, we have a key up there. So the reason I put it at 1 second for the time on the second key is because I found that that was actually a good time frame for our time lapse to occur when we have interacted with the door. The reason why we have a value of 90 is because what we're trying to do is, so with the door within our environment, it's going to start on the Y or Z or the Y or the X, kind of however you have it rotated, at a 0, and we want it to rotate 90 degrees to show that it is open, and then rotate back 90 degrees to show that it closes. So once you've got these two keys, what you want to do is you want to click somewhere and drag to where you encapsulate both keys so they are both highlighted blue, and you want to click on right click on one of the keys, and we want to do auto. So as you can see right here, cubic interpolation automatic tangents. So when we click this, you'll notice how the line curves over the delta, right, or the change or our points. So what it's doing is it is basically smoothing out our transition, because if you were to keep it linear when you interact with a door, it's gonna look kind of janky the way it opens, where it just like flips open, or it doesn't seem to kind of, you might have some like kind of jitteriness to it or whatever. Like there could be any sorts of issues you may come across in that. What auto does is it smooths out the transition, so that way when you do interact with the door, that it opens up smoothly. So that's why you'll see a lot of other YouTubers, they will do auto because of how it smooths out the animation or the rotation of whatever smoothly to where it looks nice when you actually do something with it. So now that we got that, what we want to do now is we are going to compile and save. And I am now going to close the timeline tab. And now you will see when we are back into our open close door that we now have our door delta. So now that we have our door delta track here, we want to right click into the space and do set, I believe it's relative rotation. Yeah, relative rotation. And we want it of our door because we don't want the door frame to rotate as we interact with it. We want the door to rotate as we do it. So we're going to do that, and I'm going to move my node up here for my door, and we are then going to split the structure pin of our relative rotation. So you'll notice how our relative rotation has our X, Y, and Z values. And what we want to make sure that we change when we interact with it is the Z value, the yaw, because what it's going to do is think about it as like the door attached on a pole, right? So for the Z rotation, what it's going to do, so like I said, imagine a pole and say that you have the door attached to that pole, and when you push it forward, it'll rotate around that pole. So think about it like that, which you will see in just a moment because we are going to test this, and I'm going to show you what we're going to need to fix. So off the update, go ahead and connect that into our set relative rotation, and then from our door delta, connect that into the Z just like so. So now you want to compile and save. And in order for us to now test our interaction, go ahead and hop into your sandbox character real quick and make sure that we are not within the function, that we are within our event graph. So now what we want to do is we want to add some checks to make sure that we have hit our target, and that we then send a signal to our interactables to then interact with that object. So what we want is we want to grab a branch. So I'm going to hit B and left click and then connect our exec node into here. And then what we are going to do is from our out hit, I'm going to drag down here and do a break hit result, because there is one thing that we want out of it, and I don't want to split the struct pins to get all of this when we just need one and then we can just hide it back, right? So I'm going to hang that there for a moment, and then off of our return value, I'm going to then plug it into the condition of the branch. So essentially what we're doing is the return value is if any one of these is true, if we have a hit result on anything, whether there's something blocking our hit, if we're overlapping with something, if there's something at a location, where the endpoint packed is at that location, if there is one, you know, the direction that it's facing, the impact like point, where the direction that it's facing, etc., like all this other stuff. So if any of these like return true when we hit with anything with our line trace, we want it to then go into here into true and then continue doing our interaction. So what we do need now is off the true, another branch node, because if we don't hit anything, I don't want anything to happen, just like let it die, right? So we don't want anything off the false. We want to make sure that when we do hit something that we off the true, we then do something else. So what we are now going to do is off of the hit actor. So if our line trace hits any actor within its line, then what we want to do is we want to return that information, right? Or return some information. So off of here, what we want to do is we want to grab a does object implement interface. So what this does is it checks to see if the actor that we hit has an interface or a blueprint interface of a certain type or certain class. So within our class, what we want to grab is our BPI interaction, because that is the only blueprint interface that we have connected into our chest and or into our door, and that we will be putting into our chest. So if the object that we hit or the actor that we hit has an interface, execute this, you know. So basically, if that is true, that the object that we hit has that, then we are going to then do something off the true. If it's false, then just do nothing and again, let it die. So last thing we want to do in order for us to test our door is we now want to call the interact. So off of our true, we are going to drag and look for the interact, if I can spell. And so what we want is this. We want class BPI interaction interact message, because what this is doing is within our interact type that we typed up there is it found our blueprint interface and it has found the function called interact message. So what this is doing, and kind of going again off of the examples that I made regarding like a portal, a phone, basically what this is doing is it's like, hey, we now have information, you know, from our line trace, what we broke into here, what we passed through branches, and it's like, hey, here's the information and here's what I want you to do. And it's going to then call, you know, on the phone or go through the portal to then go to our door that has the custom event and say, hey, execute your event interact, whatever your event interact has. So the door's gonna be like, hey, I received your message or your voicemail. Sure, I'm gonna go ahead and do it. And then it's gonna execute this whole thing and open up the door. And then if we were to then pass a line trace to it again, then it'll be like, hey, I got your voicemail. Let me go ahead and execute, you know, the functionality for the closed door. So, however, we're not done yet. What we need to do now is off the hit actor, we now need to hook it up into interact. And what I am going to do real quick is prettify my pins, because I don't like how messy that can get. So now you can see that we have the full functionality for interacting with our line trace, where we have a left mouse button, and this is just for debugging purposes. You can make an input action that uses the E button instead to then send off a line trace that will then do an interaction. So once we got that, so as you can see, I've closed the door and I'm going to put it back up here so it's nicer because we need nothing else out of that. So once our line trace impacts something, it's going to check to see if that actor contains a BPI interaction interface, and if so, we are then going to send an interact message just like so. So now I'm going to compile and save, and so now when we hit our door with a line trace, it should open. So when I hit play, I go to my door, you'll now see that when I interact with it, it opens and closes. So you'll also notice how it goes inward and not the other way around. So what you can do for this situation is you can go into your door where we have the functionality for the rotation set up, and what you can do is off the door delta, get rid of this line and change it to where it has a multiply node, and what we want to do is multiply it by -1. So the reason why I'm doing -1 is because if you recall, basic algebra or math, if you multiply a positive number, which if you open our door timeline, you will see that we have a value of +90. So if you multiply a positive by a negative number, you will then get a negative number. If you do a positive on a positive, you'll have a positive number. If you have a negative and a negative number, you get a positive number. So now that we have changed the door delta to be -90 because we multiplied it by -1 instead, if we compile and save it and I hit play, when I go to my door, you will now see that when I interact with it, it goes the other way and it closes when, back to its original position. So that is the very basic setup of how to do interactions with the door. So now the chest for me is going to be a little different because of how you want it to rotate, right? So now that we're done with the door, I'm going to go ahead and close out of it. However, before I do that, I am going to copy these, and you'll see why in just a moment, because now that I'm going to close out of the door, if I go into the chest and into the event graph, I'm going to get rid of all of these, and just like what we did with the door, we're going to call the interact so we have a custom event where when our sandbox character calls up the chest to interact, the chest is going to be like, I got your voicemail or I got your call. Sure, let me execute my functionality. So now I'm going to paste the content or that we copied from the door into here. And so you'll notice that the variable for is open is now gray because it doesn't detect the variable anymore within the new blueprint. So in order for us to just reset it rather than having to remake it, in this case, we can do create variable is open, and then you'll see that everything lights back up and we have our variable in here. So another thing that you could do technically is you could probably create an interactable within your BP interactable, a function that checks to see if it's open or not. But the thing is, you'd have to create a macro because the macro allows for execution pins as to where the function doesn't, allow for multiple function checks or the execution checks for the timeline. So that's why we're just basically remaking it in here. But typically, as far as best practices go, something like this is going to be used all the time or the same time for every interactable object. You want to put it in the interactable that will then be available in the chest and the door or whatever other interactable like platform, whatever. However, when I tried to make a macro, for some reason it didn't show up for me within my chest and door. So I just got to play with it a little bit more to see why. But regardless, go back to the point. Now that we have the is open in the chest, we now want to then right click and create another timeline for here. So the reason why we didn't copy the timeline from the other one is because that is specific to the door. So like I mentioned regarding parent and child classes, children are where you're going to set the specific individual aspect of what you want to have happen within that child. So in this case, I'm going to call it open close. Oop, it saved on me. I'm going to call it open close chest. And in this one, so what we are going to do is we're going to then make a rotation or a transform for the top or the lid. And the reason we're going to do a transform instead of a rotation is because it's just not that simple in this case, because what I'm pretty sure what everybody's going to want to have happen is when you look at the chest, you're going to want it to flip open or like rotate along this axis to where it opens like a lid. Well, in this case, if you were to just do a rotation, what it's going to do is, because of where it's centered at, you know, where when we set it up originally, so like if we go back into our chest and our viewport, if we look at the top, you'll see where our dot is in regards to where the middle of it is. So if we were to rotate the top, it's gonna rotate along this X or this Y. So at the halfway point, if we were to say rotate 90 degrees, it'll just rotate specifically right there, like 90 degrees wherever. So we wanted to do a transform to where it will it'll basically, like if I go down, it'll pop up and then rotate that way, so it looks like a lid opening, as you saw with my demonstration in the first video. So back in the event graph, what we need to do is we need to make 3 different deltas. So we're going to open up the open close chest, and we are going to then add 3 tracks to this. So go ahead and make 3 float tracks, and we'll name them here in just a second. And to explain why I'm doing 3 float tracks rather than 1 vector track is because the vector track's kind of weird. Like, I couldn't quite figure out how to go between these different points, and I didn't feel like, you know, it's not that hard to just make 3 different floats for the specific interaction that we were trying to do. And it's just like, it was kind of confusing me at the moment with a vector flow track. And I'm pretty sure it's simple, but for this case, what we were going to do is just leave it to float tracks because we want specific points rotating. So it didn't really bother me to have 3 different float tracks. So now we're going to go and rename the float tracks. And in this one, I'm going to call it the roll delta, because what we're trying to do is off of the X-axis, which is our roll, we want the lid to roll over, you know, on the X point. So as you can see where the red arrow is on the lid, we want it to rotate along this axis, and that's called a roll because it's rolling, like do a barrel roll basically. So if we go back into here, that's why we have it called roll delta. With our second track, we're going to call it the Y-axis delta, because what we're trying to do, the reason why we're not calling it a pitch is because we're no longer trying to like rotate it as such. What we're trying to do is move it to a new location. Like for the roll delta, what we want to do is kind of like how the door, where it just rotates on one point. That's why we're giving it a roll delta, or the name roll deltas, because we were trying to get it to rotate on one point. At this point, what we're trying to do is just move the object to a different part or a different location. So that's why I'm calling it a Y-axis delta, as to not confuse it with the legitimate animation that we are trying to do up here in the first track. So you can also call it Y-axis move delta, and then the last track you can call the Z-axis move delta, but I'm going to call it Z-axis delta. So now with doing that, what we are now going to do is we're going to start with our roll delta, and we are going to then make 2 points. So I'm going to shift and left click twice. And what we want to do is, on the first one, just like what we did with the door, we're going to set the time to 0 and the value to 0, because that is the start point. For our second point, we are going to do 1 second and 90 for the value, because we want it to rotate on the X-axis by 90. So I'm going to go ahead and fit that to graph just like that. And I'm going to then highlight these 2 points, I'm going to right click and then click auto so it smoothens out the transition when the interaction actually plays out. So now that we have that, we can then work on our second part where we then change the location on the y-axis of where the lid needs to go. So for this point, if we look back at the viewport and where we have the lid at, or the top, we want to look at where the location is, because what we want to do is make sure that we have that set, right? So what we want to do is we want this to basically rotate, if I can get it right, like so, where it's rotated up and then over probably about, I would say roughly right there. So you saw that our Z was at a 65 point, but now our Y is at a -50 because that's where we want it to end up. So in this case, what we want to do is, in order to get that location, let's go back into our timeline and let's make on our Y-axis delta 2 points. So our starting point on the Y, as you saw when we went into the viewport, it was at 0, but now it ends up at 50. So for the first point, we're going to make at time 0, it's going to be at the base location of 0. And then for our second curve, at the 1 second mark, because we need to match the time that we did for this one, it ended up at the -50 mark. However, we're not going to put negative numbers in here. We're going to just keep it to positive, so everything's on like an uplifting curve. However, you can put negative numbers in here. It's just that I like to just keep it all similar and then make the adjustments outside so as to not confuse myself. So once you have those points, go ahead and highlight, click in there and highlight both of those points and use auto to smoothen out the transition. So now that we have that, we now have to look at our Z-axis delta. So if we go back into the viewport, you can see that we end at 105 on our viewport, right? But if you recall what we had saw, you know, originally when we had rotated this, so if I rotate it back and then move it back to where we had it, it was at 65. So if we go back into our timeline, we want to make 2 points, but the first point at time 0, so at the beginning, it's at the 65 point, just like so. Where we want it to end on the end of the transition is at 105. So for this point, we want to set it at the first second, it needs to be rotated on at 105. Just like that. So let's go ahead and highlight these points, and I'm going to right click and smoothen out the transition. So now that we have that, we are basically done with the timeline. So if you look at the event, you'll now see that we have a roll delta because of where we want it to rotate on, and then the y-axis, you know, where it's the new location is at when it opens, and then the z-axis delta for where the new z location is. So now that we got that, what we want to do is we want to grab a set relative transform, because this is much easier, because we have to not only rotate, we have to then transform the location. So that's 2 different things that we need off the lid. So go ahead and grab a set relative transform pop. And what we're going to do is we're going to split the structure pin of the new transform, because what we want out of this is the rotation and the location. The scale is not changing, so we don't need to do that. So off the location, go ahead and split the structure pin. And what we are going to do is, as you saw within the viewport, how the top went from off the Z, you know, to a positive. So the Z is going to stay positive, but the Y, it had went negative because of where it had to move back. So off of our chest, I'm going to close that. Off our chest, so the roll delta, or at least the Z, what we can do is keep the Z as such because it's maintaining positive. So we want it to transform that way. And then for our Y, what we are going to do is we are going to pass it through a multiply node in order to get it a negative number, because as you saw when we moved it back in the viewport, that the number became negative. So, or the number, went even more negative, but within our timeline, we have it set to a positive number. So that's why I mentioned earlier that you can definitely put the points into a negative number. I just like to keep consistency within the timeline, so that way you can see how every graph, is pretty much, consistent or looks nice when you go into look at the timeline, but then make the transformations out here. So when you do that, we can now put the new transform for the Y and then do a times -1 into here. So I'm going to connect our update node, and I'm going to make a couple pins here just to smoothen things out, make them look nice. And then lastly, what we do need to do, and I need to move these down, is we now need to set a new rotation. So off of the split struct pin, or off the rotation, do a split struct pin, and off the roll delta, because it's a positive number, but it rotated into a negative when you saw how we rotated it, we need to also pass this through a negative multiplier, so -1 to turn it into a negative number, and then pass it into the roll right here. So again, that's why I called it a roll delta, so you know exactly what it's being called into. So last thing we need to do is we need to set up a relative scale, so that way nothing happens to our box, or maybe like no scaling adjustments are made. So off of the new scale transform, look for relative, if I can spell it, relative scale 3D off the scene component, just like that. And then we are going to grab the top from our components, and we are going to pass that in. And the reason that we're doing this is because the top, if we go back into the viewport, you can see that we have flattened it out to 0.1 on the Z, so that way it's flat. For the relative relative scale, if we would have just kept this at 111, it would have turned it back into a box when we interacted it when it opens. So by doing this, we just get the scale that's already set to our top, and it just keeps it as such because we're not making any modifications to it. We want it to keep whatever scale we set it to in the viewport. So now that we have done that, we can go ahead and compile and save. And if we now hit play and go in, we interact with the top, you can see now that it opens just like a chest. Because like I showed you, how we set it to a roll when we had interacted with it. Although I'm not sure why it's not going down now. Let me double check that. Or actually, let me just replay just to make sure I wasn't just bugging it out. Okay, it still works. Maybe I was just bugging it out because of where I was at. But again, as you can see, now we have just made some very basic assets and using a line trace based off of using a BPI interact and a timeline, and then setting, relative information, whether it be rotation or transforms. So when going back into the chest, the is opens does not mean that just using these solely will open the chest. This just allows us to get the state that it's in, so that way we can play the corresponding timeline or reverse it, and then change forward and backward like the information of, that lid or that door opening. So guys, that is pretty much it as far as our mini series for interacting with basic objects. So hopefully that was good. We were able to discuss event or interaction, BPI interactions. We were able to make 2 different forms of assets that we can interact with. And then in our sandbox character, we have set up proper functionality for this. So, this is very useful to have like within your game to interact with certain things, because you can then have different BP blueprint interfaces that do different things. So that way when you can reuse the interaction line trace and the break hit result And then if the object that you're interacting with it has a different interface or has something different involving it, then you can do, the corresponding actions or, of the object, like opening, closing, or maybe triggering an event, maybe stuff like that. Like when you interact with something, it triggers an event, potentially anything like that. So hopefully that was good, guys. I know this video was way longer than the other two. I thought about splitting this up originally, but I was like, nah, let's just go through it because there's a lot to take in at this point. So hopefully that was good for you guys. I hope y'all found it educational. So if you did like that, please check out my other videos and, keep in touch with me for future videos to come. But other than that, y'all have a great rest of your day and take care.